So for those of you, I think they've never been to my lightnings before, I'm Gaz, and everyone calls me Gaz. And this is my website, gozo.dev. I like to teach, and I'm a principal engineer at Tipalti as well. I've been an engineer for like 16 years or something. And also have a cohort. So I have a cohort and a course within Maven as well. And I think, yeah, I'm not sure. Yeah, but some of you actually joined the course, which is awesome. And we were talking about system design over there. But what was actually interesting was AI. So I think AI is a big topic. Feel free to ask questions anytime as well. I'll try to look into the chat as well. So AI is new. And one of the things that happens is like we all play around with AI, which is awesome as well. And but then the real question is, okay, so what's the best way to work with LLMs, right? So I guess we all know how AI works now. So we all use with ChatGPT. Yeah, I'm not sure how many of you are actually actively working on AI features. So that's another question as well. But how can we actually develop a system that in production we'll be better sure that nothing's going to break, right? So that's the question. So this is like 30 minutes. I'm going to present something that we're going to review some stuff together and then answer some of the questions. So feel free to ask questions as well. I can see you're all from different countries, which is awesome. And so LLMs are pretty much is a system that says, oh, so suddenly there are a lot of systems that came around like ChatGPT, or they call themselves OpenAI, and then we had, for example, the other ones, Gemini, and everything else as well. So all the requests that goes through these systems, then if we are sending it through an LLM, we get a different response, which is great. So it's good to have it so we can actually design tons of systems with that as well. So what happens when we go actually to production? So let's just, I guess, review because I'm not quite sure what's your background as well. So we want to kind of go to a bit of review of what would be the architecture of a system that uses LLM. So we're gonna talk about like what are the ordinary stuff that we're gonna do within the AI, what are the architecture the AI has, and where actually things can go wrong, and what would be the decisions that we want to make, and how we can actually make it better. So these are the stuff we want to talk about, which is like all around how the system is perceived from our point of view and the reliability, and we go from there to see how a senior engineer are shipping agent systems. So every company, they probably want to hook some sort of like an APIs. A lot of companies actually have like these endpoints that they use. So, but necessarily you don't want to just put your backend and say, oh, this is my backend, and from now on everything just goes to open API, like some sort of like AIs, and then I get a response and then I just pass the response to the front end. Yes, so yeah, this is the link. I'm just gonna pass it after as well so you can get to see it as well. So let me send the link here as well. Okay, so this is really good. Then, but in production, we can just do that, right? So it's not like, oh, I just hook it in. I just say, oh, from now on, just send a request to OpenAI using tokens, which might be expensive as well, and then you get some sort of response. So that's not something we want to do, right? So then the LLMs are some sort of a hype we all like to use in our systems, but it might be tricky to use as well. So one of the architecture that we probably keep hearing, how many of you have heard of RAG before? Just say yes in the chat. Yeah, okay, that's amazing. Okay, so some of you have used it. Yeah, I've seen it. So RAG is this fancy luxury kind of terminology these days that everyone starts just naming it because if a system wants to retrieve some sort of data, then we are like, okay, so I imagine I have like 100 PDFs and I want to search within my PDF. So it might be even more, it might be 1,000. So our company has probably over 1 terabyte of data. And then all of this data needs to be searched by an LLM as well. So what can I do? So the common approach is we have this database which you might actually use Postgres with the vector support. You might actually use the graph-based system, whatever you use. So there is these models from, for example, OpenAI and other companies. Like you can also use the open source ones. And what we do, we chunk them. So we are like, okay, so for example, you think if you want to think about it simply, you say each paragraph is a new chunk, and I want to put different chunks to this system, which is great, and just embed it to the system. So then I use some sort of algorithm provided by OpenAI, which is called embedding. Then my embedding takes these chunks and puts it into this vector database. So every chunk is linked to other chunks, right? So if I'm searching something, they're like these chunks are related to this one, and then this one is connected to this one. So, and then there's something about dimensions, like how many of these chunks can be actually connected together. So we call this pretty much RAG, right? So then this architecture is called RAG. And what RAG does is you embed something, and when you search for anything, I think if I zoom in, you're going to see it as well. So then the embedding, first you have to embed it. And then every time you query something, you actually go with the top matches that you find within your vector database. And whatever the response, then you actually send it to LLM. So the AI is actually sitting within the embedding, not within the searching. So you embed, but when AI actually wants to find something, you can actually just search it into the vector database. So you might do other stuff here as well. So what would you do? You would say, okay, so even if I want to search, so for example, this is my user query, and I just say Q, and it needs to go to the embedding. So that's what we do before actually going to the database. So what if I just put another LLM here and then say, okay, so if users search for what are the guidelines around parenting, then what if I just convert this to actually proper questions? So I might say, okay, so this question to me means 10 different questions, which is probably something that AI will understand. Then I take this to this database. So I query my vector database based on these 10 different keywords, or it might be paragraphs or whatever you come up with. And then I get a response after that by just going to the context and just shape some sort of response for the user. And then I might actually send that to LLM to make a better response, something humanly like readable or whatever preference you have. So this is what is called RAG, and it's really common to use it these days. There's a lot of like discussions around it, and it's short for retrieval augmented generation. And then that pretty much means you query, but you query your embedded chunks, and it has to sit within the vector database as well. And it works very well. There's a lot of systems actually using it. It's got its own limitations as well, so you need to be aware of limitations. But this is probably one of the really good simple ways to use AI, especially if you want to search through some sort of documents, databases, or whatever you have, and then yeah, you can easily do that. Keep that in mind. this has to be a database that supports vectors, right? So the other approach that a lot of companies actually end up doing is using AI, but for just calling tools. And what the pattern is called the React. So this is a pattern. And within this pattern, you actually go and say, oh, whatever the task I have, take it to this LLM. So LLM has the list of tools that are passed through, and my tools are some sort of like, for example, you can say there are hands for your AI that can do different stuff. Then the LLM decides what tools to call, and it calls them. So as easy as that, it just calls these tools one after another. So you might have different tools. So this is one tool, but we might have actually had like two tools. And then each one of the tools might actually get back to the LLM to call another tool. But then the whole thing is based on tools. A lot of problems that can be actually solved with this. So what if one of the tools, so you can go even further, what if one of my tools is actually searching database? So I give it full access to search database as well. So you can do that. So it's amazing. What if one of the tools is actually search Google? So I might actually give it Google as well. So you kind of go through, you might think about MCP. So it's partly a same sort of logic here as well, but that sits in the backend. So then my LLMs going through different tools, and then they get different answers. And yeah, then you go back to the users and say, oh, this is a response, right? So it's really easy to implement this. You just need to provide the list of tools, and your first LLM is going to understand. You might have a description for each one of the LLMs as well. And then your first tool, your first LLM knows what tools to call. So easy, you can easily implement it, and they might refer to it as React, or they might say just tool calling agents. So reason, act, and react, which is like pretty much easy to do. Another approach is what they call orchestrator. So this is like pretty much like the third way. Oh, sorry. This is what it's called around routing. So you have an intent. You define what sort of intent you have. So you have a message goes to the system, and for example, I might say hi. My intent is greeting. So then I'm like, oh, this is actually greeting intent. I don't want to spend my expensive tokens to respond to you to say hi, right? We don't want to do that because we don't want to spend that much money as well. So what we do is we define the router and say, oh, this is actually a simple message. So take me to my cheapest model to give it a response. Or you might actually say, no, this is actually something quite complicated. So then put it into the hard or my most expensive model, right? Or you might say, no, actually, this is a search, so I understand the intent, and then take me to the lookup, and then you define RAG. So you might have some sort of like a pipeline here as well. So you might say, oh, this is actually simple, so then find the answer and then do another thing. So you still give it direction. So everything is in your control. You can define different steps for each one of them. And this is pretty much like a cheap classifier. So whatever the classifier might be here, it might be actually text-based. You say if they use this word, or you might actually use one of the cheapest models ever to use it as a router and then define the intent and move it to the different, for example, paths, right? So this is another way. This goes on use cases as well. You can actually go and implement it as well. It's not that difficult. So Another way is to have orchestrator. So this is a bit more advanced way of doing AI, which if you have a like LLM, but this LLM can actually, whatever the AI agent that you have here, this one can decide what to do on the spot. So imagine like it has number of tools. So it might be similar to your tools, but it might actually create new agents as well. So I don't have searching booking.com agent. So what if my orchestrator decides to have a new agent and call it search booking.com agent? So this is a way that if you use like cloud code or this sort of stuff, you can see these um, AI tools, especially for programming, they fire tons of agents and they go and they get the response. So, depending on what you're asking, they might actually fire tons of agents. So, the first thing is it can be expensive. So, I've got a lot of like tokens that it might be spent because this orchestrator decides that it needs to search the entire internet for hours and hours. So limiting this orchestrator pattern is also something that you have to have in mind as well. So this, and then whatever the responsibility is, like, oh, it's research. Is it like researching 20 websites? Is it like 100 websites? How much flexibility? You give it access to the folder structures so your agents can actually look into the files. It might be a security issue as well. What if you give it access to entire database? So, and then what if it can create a new agent to fire those as well? So you can limit it as much as you want. You might say, I don't want to give it like extra agents as well. So my orchestrator can't create any new agents. It can just orchestrate. So for example, one request comes in and your orchestrator decides to say, oh, this is a simple response, just return using one of the agents. And the other query comes in and it says, no, actually, this is a 3 or 4 step program. Do a research and then do another research and then go and do, for example, review it. And then it might be a security. So you have a lot of um, decision making, but give it all to orchestrator. There are 4 ways that practically we can go with AI agents, right? If you have any questions, just type it in the chat or just say it before I go to the next steps. Okay. So, no question. This is good. So, then what we are talking about within this presentation was a bit more than the architecture that we can have within AIs, right? So, we want to talk about 3 different buckets, which is like the timeout. So LLMs can be quite slow. Is a problem. What if we have to retry? That's another issue as well. What if we have to send a message, or they think we've sent a message multiple times? Um, yeah, I guess, yeah, we can talk about that. Yeah, your friend's asking about like, what is there a good book around system design for AI agents? Yeah, I think there are. I've read 1 or 2 as well. But yeah, I think I'll cover a lot of it as well. So then, and then, yeah, your friend's asking, when you mention give your agents tools, do you just um, list out a list of MCP that are available in CloudMD? No. So CloudMD and Agent MD are actually developer markdown files. When we're talking about agents, we're talking about code, right? So imagine you use LangChain or any other tool. This LangChain has this option to define new tool. So um, there are more than actually MCPs. So you give it the tool. So there's a tool definition as a programmer. and then you say, this is the tool that does search the customer database. So they're not MCPs. You give it tools, and they're different from MCPs. And then this is how you define a new tool, whatever the framework. I think the LangChain is probably one of the most famous one over here as well. There are a few other ones, and you can use them as well. So I guess if you search LangChain versus, you can see there's a lot of them. Crew AI is one of the popular ones as well. So if you've worked with, for example, N8N, there are some sort of like similar definitions, but they're not exactly the same thing as well. So what is the difference between classifier and orchestrator? So classifier, you give it intent list. So you might say my AI has these definitions of greeting, searching, or you limit your AI to say it has to be one of these three. But when you actually work with ChatGPT now, you don't, they don't like restrict you to the intents. So there's no classifying behind the scene. So the AI decides, oh, these are the tools I have, so I can actually orchestrate it this way. And then because of that, I can respond to this urgent message, or it might be support message or whatever it is. Yeah, so that's pretty much, yeah. I think your friend just answered that one as well. So then we go with what happens. So we've got the timeouts. We have what might happen with actually system actually going down. So it might happen as well. So this is probably a bit more normal for us to handle. And then we've got the boundaries. So we talked about AI can do a lot of stuff, but what would be the boundaries? And then how do we evaluate and failure modes and this sort of stuff as well? So if you want to do a system design for an AI agent, imagine like you are in an interview. They they ask you to define this AI agent for just searching through Google, and then you're like, oh, I actually have this system, and my backend actually sends requests to the LLM, and then it gets a response, and then it just returns it, right? So first, you need to be aware of the architectures and just mention them as well. The second thing is, if you want to say you're an advanced or like a senior engineer, you need to always think of failures. So what if this fails? What if this is too slow? So what if we have to retry? So all of these ones are something you have to think about as well. So the three buckets we put into the like timeouts, retries. We talk about like idempotency, queues, rate limiting. If you want to cache some of the responses, or how do we observe, and then we talk about what if actually system fails, like the backend or the LLM actually doesn't respond, and what if about the boundaries, so how we can actually limit it. What if I ask the question about, for example, raising my children, and then the AI is going to respond me with some medical advice, which I don't like to have. So they're all something that they are like the boundaries that you have to define. So simply, an agent is a system, which is a bit slower. So if I have service and I used to call it like order service, now the AI agents or AI services are actually another service, which is just slower. So there's nothing necessarily different to call a service, apart from they actually call an external tool, and then they get a response within some sort of delay. So the delay is higher. They might not return the same result every time. So it's a lot of like limitations, but they are practically one system, right? So every tool you already reach for still, all the system design concepts we had, it still applies here as well. So the timeouts, the idempotency, and then the caching. So everyone knows with the timeouts and retries, how many times we retry. Are we going to retry it exponentially? Or is it like we want to retry it quite immediately? Or is it like we have a queue in the system, or do we have idempotency keys, or do we want to put it into queue because we want to make sure we answer everything, but the eventual consistencies are right for us as well. Of if we go with the caching and whatever we can cache. So everything we know about the system design, it applies to AI agents systems as well. So the LLM, if it goes to a system, it's just that if with a normal system, our responses were, we knew exactly what would be the response, so we could actually do a unit test. With AIs and LLMs, it might actually be different because the response might be different texture structure. Or if you requesting to get JSON structure, if you use the, the AI might return different JSON keys every time. So throw an error you catch. That was something with the normal service. But with these ones, it's mainly around text, right? So it might return some sort of text, but might be an error. So you don't know. So this is a bit different. The normal service is we were counting on request, but within LLMs we always discuss tokens. The latency of the system or any, for example, service, it might be like a Golang service or might be like Node.js, is milliseconds. But within LLMs is usually 3 or 4 seconds. Like if you go with 1 second, you probably is a smaller request, but 3 or 4 is probably really normal within LLMs. And they are testable with the normal services, so we can actually test them, unit test them. But with these ones, a bit difficult because you don't want to call the LLMs every time to say, oh, this is something to test it every time. So what we do, we might actually mock a lot of like responses of LLMs to just make sure our code before reaching out to LLMs are actually working. And you might actually have like one end-to-end test or something, just call the one of the cheapest models as well, just make sure the integrations are there as well. But you don't test them, or you don't test the response as much as what you could do the normal system. So what we are engineering with most of the context is what we want to put into the context that it goes to the LLM as well. So if we are working with ChatGPT or Gemini, we might not care about what we put into our context. But we all probably experienced if we put a lot of messages through our context, it starts hallucinating, right? So we don't want to do that. We don't want to put a lot of data into our context. So the context management of what you're sending to LLM becomes important. So the system prompt, whatever you want the LLM to do, what was the history, how you want to have the retrieved context. So you might have the rack system, and then what tools you give it or you make it available so the AI can actually give you a response based on the tools. So, or it might tell you, you call this tool after this, right? So whatever you do, the state of your system. So before, within my Node.js servers, my state was my local tenant context, whatever I had within my system that could handle the JWT tokens or user. But within LLM systems, it goes around the state of the context, which is whatever the context I'm managing, that goes within your system. So it's a bit of a different mindset of thinking about it. So you have to actually have a context window and think about what you want to put into different contexts, right? So then you have to decide 4 different things. First is, what are the boundaries? What is allowed to do and what is not allowed to do. So every stuff you do, so every response you're getting, how you want to set the boundaries. Do you have guardrails? Do you say, oh, we only answer these things, or whatever the context of a system prompt is? It might actually help here as well. So then we're talking about states. You don't want to put all the context into the request. What you actually put into your request, that's something as a production system you need to define. And then you go with the failure modes. So what if the AI returns something wrong. If the schema or whatever the response I expected it to get, it just doesn't return it. Or what if my AI response is not within the boundaries that I need to answer? Is it like because we reach out to ChatGPT? My product is about construction. If someone asks about Elon Musk, I don't want to answer that question. So, how do you handle these things? And how you have human in the loop sometimes because you might need a human. So that might be a lot of failure modes that you might actually do. So a lot of systems might actually define something to say, if this one failed or this AI is failing, go to the next AI. Or sometimes you're like, okay, so if nothing get back, go to use my local AI or just shape some sort of response not as beautiful as AI would return, but still we can shape it ourselves as well. Then the evaluation, you can't unit test, so that's a problem. So evals become something that you need to think about how you have it defined within the system. Um, yeah, I'll do it at the end as well. So the agent loops we're talking about how to so the agent loops we go with the how assemble context, what are the model plans, what's the tools, and then we go with the validating and just making sure what calls we are validating or how we validate or how we execute those AI calls, and then we go at the end and just say update it, right? So if you can test it, which is like based on your schema, you go with the first one, and if you can't, you go and you either need to go with the guardrails or it's actually something, for example, you have an AI system that needs to go through these documents. So you might put it somewhere for a human at the end to say, confirm whatever we're reading from these contents are actually correct. So you might have like approved by a human at the end of AI calls as well. So the reliability and cost is something which is important. So you don't want to go with how many retries, or you don't want to send the same message too many times. And then what's the latency? Like, is it acceptable for the system to retry a few times? The all questions that you want to have it answered within your reliability and cost definitions. And then you don't want to put a lot of tools or expensive tools to your system. They might actually end up easily spend so much money there as well. So an agent system is practically a distributed system. There's a lot of like concepts that we had with the system engineering still applies here as well. And then so this is we took them more than 30 minutes now. There a friend of yours asking about AI agents. So I think there's this book called System Design for AI Agents, literally, and that's something I think is quite famous. Yeah, so I think you can read that one. So, like designing data intensive applications, that's something you can do. And yeah, application building applications with AI agents, that's something probably worth reading that you can do as well. And apart from that, I've got my own course. It's called Production Ready Systems with LLMs and Agents. So I'm going to go through this course, which is all around how to build these systems or what are the practical ways to go, for example, for the defining boundaries or going with the right agent architecture, or how do we design the failures and timeouts and few examples, and we build systems and so on. So this is also something that um, I'm kind of presenting within Maven as well, so you can actually have a look. And this is pretty much it. I think if you have any questions, just shoot it in the chat, please. I think we can spend like another minute or two to respond. Any questions? Okay, no question. Yeah. Thank you so much, guys. Hope you enjoyed it. Uh, Keep yourself updated with the latest designs and how the AI works. And yeah, let me know and you all can reach out to me in LinkedIn. And thank you, everyone. Thank you. Have a good day. Have a good rest of the day. And I guess I'll see you next time. Bye.